Cross-site scripting. So this is a complex topic. We'll cover this quite a bit in different ways and quite a few labs on this and show you how to exploit these and look to see if the systems are exploitable or susceptible or vulnerable to this kind of thing. So a type of vulnerability typically found in web applications requires that the HTTP only flag be set for testing only. For the test only, okay, so what this means is this is a test question, but in real life, it doesn't necessarily mean that you have to have this HTTP only flag set. Sometimes you can get this to work other ways as well. An abbreviation for this is XSS, means cross-site scripting. It enables attackers to inject client-side script, so client-side reaching out to a server, web pages viewed by other users. So it enables attackers to inject client-side scripting into web pages viewed by others. So you've got a user, he reaches out to a server and injects some code in there, and then that code gets stored, and then it serves it out to other users. They click on the infected page and are redirected back to you or your server in some way. It may be used by attackers to bypass access controls, such as same policy origin. And in most basic form, this is what it'll look like. Image source equals vbscript.messagebox vulnerable. So when you click on something, you'll see that pop up. So the original attribute equals source. The origin path equals vbscript.messagebox vulnerable. So anytime you see the word vulnerable pop up, you'll see that that page is susceptible to cross-site scripting. It can be mitigated through output encoding. So cross-site scripting, part 2, or slide 2. So we're going to follow the path here. So we start with the 1 over here, and then the 2, 3, 4. So this is how the communication occurs. So you have an attack server who's, you post some cross-site scripting scripts into a site. It gets injected and stored in the script. So it's usually done for dynamically built pages where the information is coming out of a database. So you've performed some injection, you got it stored in the database, and now the server, somebody requests a page and the server pulls that data out of the database, and this web page presented is infected. So now number 2, the user clicks on a link. The page, they send the page with a cross-site script down to the user. They click on something in the page on the actual client, and now it sends back valuable data to the attack server. So that's kind of how the life cycle works of a cross-site scripting attack. There's another type known as a cross-site request forgery. Cross-site request forgery, also known as a one-click attack, also known as session writing, and abbreviated as CSRF, sometimes pronounced CSRF, or XSRF. It's an attack that forces an end user to execute unwanted actions on a web application in which they're only currently authenticated. Targets state-changing requests, not theft of data, since the attacker has no way to see the response to the forged request. With a little help of social engineering, such as sending a link via email or chat, an attacker may trick the user of a web application into executing actions of the attacker's choosing. If the victim is a normal user, if the victim is has an administrative account, if they're an administrative user, then they can compromise the entire web application. So at best, you're just getting them to click on a link, which is very common. You can have ad click servers, so when they click on something, they get 10 cents or 1 cent or $1 or whatever it's worth. So the more clicks they get, the more money they get. They think they're clicking on, hey, I want to send money somewhere, or hey, I want to open this music file. They click on the link and actually they've just clicked on an ad server. So they may not even know that it's happening because they can redirect them and things of that nature. So they're very complicated how they work. Not complicated how they work, but complicated in how the facilitation is done. Sometimes they'll see the real ad and they know they're infected, kind of gives up the gig. People tend to be a little more stealthy today, so they may serve up the ad, and it just looks like the page took a little longer to load. You didn't see the ad, it's in a hidden inode, things of this nature. They get pretty complex in how they work. If the victim had an administrative account, they can actually compromise the entire web application. They're mitigated with special libraries that are designed for this. OWASP has one, has a CSRF protector project consisting of 2 parts, an Apache module and a PHP library. The mitigation is done by handing out tokens so that every time the page is loaded, you know that it came from the right source or a trusted source. So the phish occurs, the Crosssite's handed out, and the request comes back. So this is how they look when they're done and executed. The mitigation doesn't always work in real life. So that's what this covered text is kind of talking about. The mitigation doesn't always work in real life. But basically with randomly generated cookies, cookie tokens actually, randomly generated tokens, this is how you protect against cross-site request forgery. But again, the token itself is not enough. So the client and the server have to do a lot of communicating. Now we're going to talk about a tool called Netcat. Netcat is considered malware by most AV vendors. And I have the logo down on the bottom right here, the little cat, the symbol cat. So if you see this anywhere, you know that this is a Netcat related tool. Many tools will use Netcat under the hood. The signatures will match the Netcat binary, and it'll be considered malware by most systems. So if you download it into an org, you may set off all the alarms. So if you're at work and you're watching this video and you want to play with Netcat, spin up a VPN tunnel or don't download it at work. So it's often abbreviated by NC. In fact, that's the command for it, to fire it off once you have it downloaded. It facilitates reading and writing to network connections using TCP or UDP. It was not created to be a hacking tool, but is often used as one. So it can perform port scanning, transferring files, and port listening, and can be used as a backdoor. Say you want to open a raw connection on port 25. Here's the command to do it. By the way, you might see this on the test. ncmail.server.net space 25. That's how you would do it. Open a raw connection on port 25. If you want to listen on port 2222 and output anything received to a remote connection on 10.1.0.43 on port 1234, here's the command to do it. You may see this as a test question. nc-l for listen, -p for port 2222, pipe it to Netcat, another Netcat instance on 10.1.0.43 on 1234. That's the command to do it. It's very powerful, and that's why it's used as a hacking tool quite often. So there's ways to armor the binary so that when you download it, it won't signature match, so you can get it on your machine and execute it. But if you have AV running on your client, it's likely to get tagged. If you wanted to scan UDP 0 to 1024, here's how you would do it with Netcat. So if you want to scan for UDP traffic on 0 to 1024, or see if there's UDP ports open on 0 to 1024, here's how you would do it with Netcat. Netcat or nc-u-v-w2, the host name 1 to 1024. You're going to see that all these as test questions. So make sure you're familiar with this tool. There's also a lab to go along with this one.